All right, in this video, I'm going to be talking about radical expressions, square roots, third roots, nth roots, fraction exponents, really kind of the mechanics of dealing with these for college algebra. Okay, so we're going to start with the square root of 9, which is kind of saying, find me a number where if I square it, I'll get 9. That's what it means to be the square root. Okay, so a number x where x squared equals 9, well, that's 3. Okay. Now, when we see the square root already written on the page like it was on your sheet of examples, okay, that means the positive square root. It's not, one or the other. It is the positive square root of 9, which is 3. Okay, so we're looking for a positive number x where x squared equals 9. And now let's think about 9 to the 1/2 power. Does anybody just know what 9 to the 1/2 power is? The same as?
1 over 81.
Okay, yeah, so so we've got like that would be 9 to the negative 2. And I feel like somebody might have said it, but if you're having trouble remembering or why this is true, I'm proposing that 9 to the 1/2 power is the same as the square root of 9. So what I'm going to do is I'm going to kind of just do a little bit of experimentation. If 9 to the 1/2 is the square root of 9, when I square it, I should be able to get 9, right? So 9 to the 1/2 squared is equal to, well, this is the situation where I multiply the exponents, so 1/2 times 2. And so that's 9 to the 1, which is 9. Okay, since 9 to the 1/2 squared is 9, 9 to the 1/2 is a square root of 9, which is to say that it's 3. The square root of x squared, okay, you might be thinking, well, it's just x. Really, this probably should be the absolute value of x, but for the purposes of this class, I really don't think that distinction is going to be important. So what I'm going to do is I'm going to say, well, the square root is the 1/2 power. Okay, this is where we multiply the exponents, so x squared times 1/2. And this is x to the first power. So the square root of x squared is x. And then, I know they'd also ask you about the square root of x to the 6 is, well, that's x to the 6 to the 1/2 power. The square root is the 1/2 power. And that's x to the 6 times 1/2, which is x to the 3. So we know that if we have like a power of some variable, and then we square root it, we're going to have half the power. So I know y'all know, square root is the 1/2 power. That's one thing that we're going to keep coming back on probably throughout the rest of the course. Okay, next they're talking about the third root of 8. Now the third root of 8 is a number where if I cube it, I'll get 8. So I'll say a number y, where y to the third equals 8. Okay. And, well, that's going to be 2. If you take 2 to the third, you get 8. And it says, well, 8 to the 1/3 power. Okay. Again, I'm proposing that the 1/3 power is the same as the cube root. Okay, so if that's true, then when I take this number to the third power, I should get 8. Right? If 8 to the 1/3 is a cube root. Okay, so this is 8 to the 1/3 times 3, which is 8 to the 1. Okay, meaning that 8 to the 1/3 is the third root of 8, which we just said was 2. And then when it asks us for, expressions involving x, okay, the third root of x to the third is, the third root is the 1/3 power. Okay, so that's it. That's just x. Okay, and then say the third root of like something, say x to the 6th, is going to be where I'm going to divide the 6 by 3. So x to the 6 to the 1/3 power is x to the 6 times 1/3, or 6 divided by 3, which is x squared. Okay, so again, I'm saying that the cube root is equivalent to the 1/3 power. And you know what? Moreover, I think I could, maybe shrink this down a little bit and say that if I was taking like the 7th root or the 21st root or something, the nth root, that's equivalent to the 1 over n power. All right, over here it's asking for the square root of -9. Bless you. And, well, you know, you can put that in the calculator, or maybe you just know from earlier in this course, this is not a real number. Now, soon enough, we're going to, I think even like maybe 2 times from now, we're going to say that that's going to be 3 times the square root of -1. And we'll have all sorts of stuff to say about that. But for now, we're just going to say that this is not a real number. Over here, when it comes to the third root of -8, well, you're looking for a number that if you take it to the third power, it equals -8. And this is going to be equal to -2. Because if you take -2 to the third power, you will get -8. Now, what I'm going to start doing here in a little bit is, okay, we can see that it's, well, the negative on the -2 came from the negative inside of the radical, and the 2 came from the 8. So really what this means is that the third root of -8 is equal to the third root of -1 times the third root of 8, right? And the third root of -1 is -1, and the third root of 8 is 2. So this is evidence of some sort of like bigger thing going on. All right, so the relevant fact or theorem or whatever is going to be that if you have the square root of the product, or really the nth root for any root, the root of the product is the product of the roots. Okay, so that's square root of A times square root of B. And this also works for division. Okay, and why does this work? Let's just look at, say the square root of 9 times 4. Is the square root of 36 equal to 3 times 2? Yes, it's 6. Okay, we know that this works. Okay, we saw it with the third root on the previous example. All right, another relevant fact is that the square root of the sum is not the same as the sum of the roots. Okay, you cannot just say that's root A plus root B. Okay. It seems like this is a more common error for y'all to try to make than to, if it's A plus B squared is not A squared plus B squared. I'm not really sure why. It's the same idea. But it is tempting, and I'm telling y'all don't do this. And let me demonstrate why this is not true. Okay, the square root of 1 plus 1. Okay, well, look at the square root of 1 plus the square root of 1. The square root of 1 is 1. So this is 2. The square root of 2 is not equal to 2. We know this. The square root of 2 has got to be less than 2. So don't do that, right? Avoid that if at all possible. All right. So write the expression as a power of 31. Okay, this is the type of question that you're going to be asked, on a quiz or a test or something. It's going to have, an expression involving some sort of radical, and then it's going to ask, what's the real power here? So maybe we've got something like, 31 fifth rooted taken to the 7th power. Okay. Well, we know that the 5th root is the 1/5 power. So this is 31 to the 1/5, then taken to the 7th, and then that's where I multiply the powers. So 7 times 1/5 is 7/5. Correct. All right. Then we've got maybe something like, the square root of 31 to the 11th or something. Well, this is 31 to the 11th to the 1/2 power, because we know that the square root is the 1/2 power. And then I take 11 and I multiply it by half, and I get 11 halves. Oh wait, 31 to the 11 halves. All right, so this is the type of problem that you can expect to see on a quiz that, the calculator won't really help you that much. And while I'm at it, here's another one. 31 times the square root of 31. Okay, what power of 31 is this? Well, you take 31 and that's 31 to the first, and you multiply it by 31 square rooted, that's the 1/2 power. And in this situation, this is where same base, different exponent, that's where we add the exponents. Okay, so this is 31 to the 1 plus 1/2 is 1.5. You can write 1.5 if you want, no judgment. I'm going to write that as 3/2. However you feel. Next, I'm going to talk about rationalizing the denominator. And this used to be a big deal back before calculators were so proliferated. And I'll explain why in a couple minutes. But you've done this before, most likely in a geometry class. If you took pre-calculus, then you definitely had to do it in that class. What used to, okay, so the example is something like 9 divided by the square root of 5. Okay, you run square root of 5 through a calculator, and, it's going to be, just a second. Okay, square root of 5, 2.2360679, whatever. And we know that because it's a square root of a non-perfect square, it's an irrational number, meaning it has a non-terminating decimal. So you can approximate this, as close as you like. But if you went to divide 9 by this, you have to think really far back to, wherever you went to elementary school, a long time ago for y'all. And, if we were to try to divide 9 by 2.2360679, that's going to be really unpleasant. Because remember that the more decimals you have in the divisor, the more unpleasant long division is. Okay, so this is a huge deal. What you can do, and what you probably remember from, geometry or pre-calculus or whenever you did this, is you take 9 over root 5 and you multiply it by, the right form of 1. So I'm going to multiply it by root 5 over root 5, which is just 1. And then square root of 5 times square root of 5 is equal to 5. So I have 9 square root 5 divided by 5. Okay. And so if I took 9 root 5 divided by 5 and I had to calculate this by hand, okay, so you multiply this, choose as many decimals as you want, multiply by 9, you're going to get, I think, 19 point, some other stuff. And then you go to divide that by 5, that's something you can actually do by hand. Okay, especially in times where you had to look up square roots on a table or, go to the computer room and schedule time to calculate your square roots, like my dad did when he was in statistics. I mean, we're talking about late 60s here, but, this is why they used to rationalize the denominator. So anymore, we don't care about that, right? Except for the fact that in a multiple choice scenario, almost always the answer choices have rationalized denominators. So you have to be able to recognize equivalent forms of the same number. So, you're working something, you end up with 9 over the square root of 5. You're probably not going to see that amongst your answer choices on a multiple choice test. Most likely, this thing here that I'm highlighting in yellow is what you're going to see. Okay, so we just need to realize that those are the same thing. The good news is that if you grab that scientific calculator you got sitting on your desk and you use the fraction bar and you do 9 divided by the square root of 5, provided you are in math print mode, it will just do that for you. Okay, so that's really nice. This is not a big deal. Let the calculator do the work. Next in the packet, we've got, a bunch of things that want to be simplified. You want to assume the variables are positive, and you want to rationalize the denominator. Okay, well, this is the thing where we're going to use that property I was talking about earlier, where we can split this off into the 4th root of 81 and the 4th root of x to the 12th. Okay, the 4th root of 81 is something your calculator can help you with. The 4th root of x to the 12th is not. Okay, so, that's going to be on the quiz. There's going to be ones with numbers and variables. The calculator will always help you with the numbers. Variables, not as much. Okay, the 4th root of 81, you can type that in the calculator, or maybe you just know that it's 3. Okay, so I'd say just, I use the calculator. No sense in getting that part of it wrong and then ending up with the wrong answer, Okay, so there's 3. And the 4th root of x to the 12, is x to the 12 taken to the 1/4 power, so I divide the power by 4, and that's going to be x to the 3. So that one's just 3x to the 3. Okay, the third root of 27x to the 6th, again, I'm going to split that off into the third root of 27 times the third root of x to the 6th. And okay, the third root of 27, either you just know that that's 3, or maybe you run that through the calculator. Either way, no big deal. It's 3. And then the third root of x to the 6th, we're going to divide the power by 3, so 6 divided by 3 is 2. So it's 3x squared. Okay, with 25x to the 4y to the 6, again, okay, I'll make that square root of 25, square root of x to the 4, square root of y to the 6. Okay, square root of 25, I know that's 5. Square root of x to the 4, half the power is x to the 2. And square root of y to the 6, half of 6 is y to the 3. Okay, so 5x squared y to the 3. And here's one that really is fundamental to what we're doing today. 50 divided by the square root of 50. Does anybody just happen to know what that is just from looking at it? Because you are comfortable with square roots, or you see what the pattern is here? No? Okay. 50 divided by the square root of 50, well, that's kind of like 9 divided by the square root of 9. And that's 3, right? If you take, say, I don't know, 25 divided by the square root of 25, you end up with the square root of 25. Because, okay, so I'm going to just say that this one on the left is the square root of 50. Because you could look at it as 50 is the same as the square root of 50 times the square root of 50. Then you could cancel these factors. Or maybe you could take 50 over the square root of 50 and rationalize it like you did in geometry class by multiplying by a clever form of 1. And then, okay, well, that's 50 square root 50 divided by 50. Either way, you're ending up with just 1 square root of 50. Okay, because that's really what it means to be a square root, is that, you know, if you divide the radicand by the square root, you're going to end up with square root. Okay, here's one that's, you know, different looking. Okay, what I need to do is I need to simplify the radicand before I actually take the third root. The radicand being the thing inside of the radical. So this is x to the 1/4 minus 5/6. Okay, and maybe you do that arithmetic by hand, or maybe you use the calculator for that. So when I put those together, I'm taking this third root of x to the negative 7/12. Now I know that the third root is the 1/3 power. 7 and 3 don't have any common factors, so this is going to be x to the negative 7 divided by 36. Yeah, that is certainly different. Okay, when you multiply two cube roots, you've got a couple of options. I feel like you could do this one of two ways. You could either say, well, I'm going to turn this into fraction powers. So this is x to the 7/3 power times x to the 2/3 power, which is where I'm going to add these powers. So that's 7/3 plus 2/3 is 9/3. Or you can kind of reverse use that property that we were using earlier and say that this is the third root of x to the 7 times x to the 2, which is the third root of x to the 9th, which is x to the 3. So it's really, you know, how do you want it? Simplify by factoring. Okay, so we've got something like 2x to the 3/2 plus 3x to the 1/2. Okay, and we're going to factor out an x to the 1/2 here, and hopefully be left with something nice. Now, before we do that, though, I'm going to kind of talk about factoring more in general. And so when we, you know, looked at 18x to the 8 plus 27x to the, let's say, 3. Yeah. It needs to be less than 8. Okay, so I think what's common to both of these? Well, I think there's 9 in common to both of the numbers, and there's at least 3 powers of x. So I'm going to factor out a 9x to the third. And then when you go and you say, okay, what would I multiply 9x to the third by to get 18x to the 8? Really what you're doing is dividing 18x to the 8 by 9x to the third. Okay, and so 18 divided by 9 is 2, and x to the 8 divided by x to the 3, that's x to the 5. But what my point is that you're subtracting. You're taking 8 minus, you're subtracting 3 powers. Over here, you've got 3, and you're subtracting 3 powers, so you're left with no powers of x. Okay, looking at this, I'm going to factor out the x to the 1/2 power, and I'm left with that 2. And so I subtract the 1/2 power from the 3/2, and I get 1 power. And then plus 3, I subtract the 1/2, and I get no powers of x. Okay? I suspect that this would be useful if you were trying to solve this equation. It would make it a little easier. But more on that next time, because that's what we're doing next time, is solving equations. Right, over here, I'm going to factor out the x to the 1/3 because I can see with the 4/3 it's going to leave me with 1 power of x, which is maybe something I could potentially work with. So I'm going to factor out an x to the 1/3. And it looks like I can also take a 2x to the 1/3. And I'm left with 3x to the 3/3, because I take 4/3 minus 1/3, plus 2 times 2x minus 3. I lost the 1/3 power, I had no power left. Okay, so this is 2x to the 1/3 times 3x, and then I'm going to need to distribute this positive 2, plus 4x minus 6. Okay, so this is 2x to the 1/3 times 7x minus 6. And this is something that you could more easily solve if it was set to 0. All right, now distributing or simplifying with multiplication, this is something that's much closer to what you might be asked to do on, say, a quiz next time. Okay. The other thing, the factoring, is something that will help us solve maybe next time. So, but for the quiz next time, you probably are more concerned with distributing. So we know the distributive property. I got to multiply the square root of x by both of these things. So this is 3 square roots of x minus 4 times the square root of x times the square root of x. Now we know that the square root of x times the square root of x is just going to be x. So, and so that's 3 root x minus 4 times regular x. Okay, another one, I'm going to, start by doing that. Okay, that'll be 3 times the cube root of x plus the third root of x times the third root of x. Well, that's like the third root of, I can put them together and say that's x squared. I don't really much like that, it's not ideal. I'm just going to, this is all equivalent to the right answer. What I'm going to say is, or a more simplified answer, but I'm just going to express these as fraction exponents because it's what I'm trying to, impress on y'all today, that the third root is the 1/3 power, and the third root of x squared is x to the 2/3 power. Okay. Okay, just like when we squared a binomial that didn't have any radicals in it, you cannot just say that this is x minus 2. Okay, so I'm going to just remind y'all of that. This is not equal to x minus 2. Please don't do that. Okay, what you need to do is you need to set up for FOIL. So this is square root of x minus square root 2. Square root of x minus square root of 2. First is going to be root x times root x is equal to x. Outside is minus square root of 2 times square root of x is square root of 2x. Inside is minus square root of 2 square root of x is square root of 2x. And last is plus square root of 2 times square root of 2 is regular 2. Okay, and then combining like terms, I've got x minus 2 of these square roots, and then add 2 at the end. Okay, don't forget that middle term when you're asked to do this, whenever you are asked to do this. All right. Okay, here we've got two things that are off by, see we have root x minus 1 and root x plus 1. Okay, so this looks like something that we factored using difference of two squares, really. What I'm going to say is that these are conjugates, so they're radical conjugates of each other. And we'll have more to say about conjugates, especially when we go to do complex numbers. But for now, I'm just going to remind you of this. Oops, didn't leave myself enough blue space. That'll be all right. Okay, so what we do is we're going to FOIL, and you'll see this will eliminate it'll eliminate the radical. So if that's something that you wanted to do, you could multiply a fraction on top and bottom by this to rationalize it. So square root of x, or times square root of x is regular x. Outside is plus 1 square root x. Inside is minus 1 square root x. And last is minus 1. But then you see that the plus square root x and the minus square root x, it's going to add to 0. And so I just have x minus 1. That's real nice. All right, the last thing we're going to talk about in this video is evaluating expressions with rational exponents, so like a number to a fraction exponent. This is the type of thing that in our college algebra class you're allowed a TI 30, so you probably could just use the calculator for that. If you were in the college algebra course at ACC, however, you would most likely not be allowed a graphing calculator, and you would need to be able to do this yourself. So I'm just going to give you my general best advice for this, and that is deal with the denominator first. Okay, so one easy example would be 4 to the, let's say 5 halves. Okay, if you could take 4 to the 5th and then try to figure out what the square root is, but I don't really know what 4 to the 5th is, and I certainly am not going to know what the square root of 1024 is. Yeah, I don't know that. Okay, so what you're better off doing is saying that this is the square root of 4. Deal with the denominator first. The 1/2 power is the square root taken to the 5th power, which is 2 to the 5th, which is 2, 4, 8, 16, 32. Okay. We have something like, I don't know, 64 to the 2/3 power. Okay, well, I don't know what 64 squared is, but even if I did, I'm definitely not going to know what the third root of that number is. So what you want to do is you want to take the third root of 64 first, deal with the denominator first, and then square it. Well, the third root of 64 is 4, and then you square it, and that's 16. Okay, that is, in general, how I recommend you deal with numbers with fraction exponents, is take the root, using the denominator of the fraction as the index, and then take it up to the power. So you keep the numbers in control. If you've got a calculator, this is not relevant because you're just going to use the calculator for it. But if you have to do this by hand, this is what you need to do.